Well, welcome on back to Ocean Currents. I hope you understood that public access. We really appreciate that public access channel putting together some great material to teach our kids in this time. Thank you for those actors and everyone that was a part of that. What a great thing that we have to put as a resource out there for our families here at Cheney Middle School, Westwood Middle School, and anyone in the Cheney School District that might be tuning into Westwood's public access channel. Now we're going to look at currents in the ocean. One of the things that we talked about in the past was those prevailing westerlies. The prevailing westerlies. Those are those winds that are moving from west to east. And as they do, they tend to kind of turn slightly. That's because the earth is turning on its axis. And because the earth is turning on its axis, things don't tend to go north and south on a straight line. They tend to deflect just slightly. And so we get these things that we call, it's due to the Coriolis effect, these westerlies, prevailing westerlies, turning just slightly. And as these prevailing westerlies are doing this, we have a high pressure system down below. This is due to the heating in the equator. We have a lower pressure up here. This is due to the fact that our air is moving up in that cooler area. High pressure down here is that warmer air. And so as we have our highs and low pressures spread out, we start to see these arrows pointing in the way of these westerly winds. Now, the global wind patterns are caused by the unequal heating of Earth and the Coriolis effect. Surface ocean currents happen as these winds blow across the ocean. They push the water in the direction the winds are moving for great distances. And here in North America, we have a really great example of this. In fact, there's a really strong ocean current that makes its way up our east coast of America here. Here's New York up here, Florida down here. And as you can see, this east coast, it makes its way up. Warm water, which we see associated with that wind, is pushed up from the equator. And as it's pushed up, it actually travels all the way into the Arctic. We've talked about this before. And in fact, Iceland, which is this little island right here, is warmer despite the fact that it's equal to Greenland, this giant ice island right here. The reason being is we've got this Gulf Stream, we call it, because this is the Gulf down here, a stream of current of warm water that makes its way all the way up, and it comes right in past Iceland, creating a milder climate. So it's not quite as cold in Iceland as it is in Greenland, despite its name. And as that Gulf Stream moves up, some of it kind of moves down towards Europe and circles down this way, but some of it actually moves all the way up to one of the northernmost places people live, and that's the place of Svalbard. That's that place that we talked about actually when we talked about a really unique area built into a mountain of Svalbard. And that really unique area is so fabulous because the World Seed Bank exists there. So people say, well, what's worth more than paper money? Well, obviously seed, because you need food. So the seeds of most everything in the world people have invested into are stored in a bank that's up in Svalbard, which is in the closest place. It's away from any threats or anything that's going to be in the way of destroying it. And it's actually built inside of a mountain, so it's pretty safe inside there. But that warm Gulf Stream water, that ocean current, is pushed all the way up to Svalbard. And Svalbard actually has a place, despite being in the Arctic, where you can swim in the summertime, which is pretty crazy when you think you're in the Arctic Ocean. But there are people that actually swim in the summertime up there in Svalbard. With these ocean currents, again, here's the Gulf Stream coming right up off of Florida and the Carolinas all the way up through New York. And there's a place called Cape Horn in North Carolina. Cape Horn is famous because we could actually take a measurement of how much water moves past Cape Horn from this Gulf Stream. And they found out that 80 million cubic meters of water moved past Cape Hatteras, Cape Hatteras each day, which is crazy. You take a meter stick from Mr. Jensen's classroom and you make a box cube. Take 80 million of those, stack them up on each other, and pass those things right past that point that tells you how much water is there. And in fact, if you've ever seen an old 80s classic movie, Jaws 2, that was one of their fears, is that as they were lost adrift at sea, they would miss one point of contact that they could get help from, and they would float the Gulf Stream all the way up to Ireland. If you've ever seen Jaws 2, you'll understand that. But if you haven't, then maybe it's a Netflix rental for you. I don't know. But again, there's these stream of currents, And people that get lost at sea get stuck in these currents all the time, and they're at adrift in the sea, and wherever the current takes them is where they go. In fact, we have lots of teeming life that we call the drifters. The drifters, like a jellyfish, for instance, are these animals that live inside of these streams of currents that go through. They call them drifters because they just drift with the current. Surface currents usually carry heat, though, from the equators to the poles. Remember, the big thing is wind makes ocean currents. Wind makes ocean currents. Now, there's a thing that I want you to see, which is when this Gulf Stream comes up and through, it actually does take a dive down the North Atlantic and comes back through this area of North Africa, Europe, close to the Mediterranean Sea opening. And in that, we create another pickup, which is the North Equatorial, down in the south, and it creates this spinning thing that we call a gyre. Ocean currents create a giant gyre right out in the Atlantic Ocean. And in fact, there might be a chance that we get a really good article next week that you can read about this gyre, because ship vessels used to actually travel through this area, and they had to strategically pick their winds based on how they're going to make it across the sea. But there's some interesting facts about this North Atlantic gyre that I think you might enjoy looking up. Formed when ocean currents cause large rotating systems. This is because of the Coriolis effect and the shape of our coastlines as well. Coastlines have to do with this. It changes the way the water flows, being that it's the shape of our coastlines. It also is the Coriolis effect, turning as it comes from north to south, south to north, things like that. And the North gyres rotate in a clockwise direction. If you look at the clock in Mr. Jensen's classroom, you'll see that it's going clockwise. That's the way that the clock spins, remember? This is the way that this gyre spins. However, counterclockwise happens south of the equator. So north of the equator, clockwise. South of the equator, counterclockwise. People always think that's so weird. If you flush a toilet in the north, does it spin clockwise? And flush a toilet in the south, does it spin counterclockwise? I'll have to test that one out. I won't tell you. South of the equator, gyres rotating counterclockwise. So they're opposite south of the equator. But here we are with our westerlies and our trades. They call these the trade winds, and they call these the westerlies. And you can see the direction that these are pointing and that these are flowing as far as the winds go. When we get those big hurricanes, boy, those trade winds bring that warm air right over the Atlantic and into this area here with a high low pressure system. That's what creates our hurricanes. Warm water right up in here. But a nice high pressure system would build that thing out. Westerlies pointing up in this direction. There's our Gulf Stream flowing all the way up. There's our North Atlantic gyre right up in here. Gosh, I bet you could tell me that there's a south gyre down in here going in a counterclockwise direction. You're absolutely right if you're onto that. Well, in summary, see if you can answer this question. What causes surface currents? And how do ocean surface currents affect climates around the world? Let's just do a quick check. Right below this video is going to be a question. I'd like you to put in your own words, please. If you need to refer back to the videos, you can, of course, but answer that question. What causes surface currents? And how do ocean surface currents affect climates around the world? Give that a shot. Excited to see your answers. And once again, thank you so much for doing this, and excited to see what we have. Have a great day.